Hi, hello, ladies and gentlemen. This is Mr. Weideman, Pre-Calculus, Lafayette High School, and today's lecture is we talked 8.1, and we talked about polar coordinates. We spent a lot of time on what they are, and then we got to this part where he says, okay, just a quick recap. How do I convert a polar coordinate to a rectangular coordinate? And these are our two hinge pin formulas for doing that. And so if I got a polar, I can quickly figure out the x and y coordinates in rectangular. There's our example problems. You can pause and take a look at that. We went backwards. We had a rectangular coordinate, and we converted it to a polar, just using Pythagorean and a little bit of inverse trigonometry. Any rectangular coordinate can be thought of as a right triangle trigonometry. The x-coordinate, side adjacent, the y-coordinate, side opposite. All right, and then we did an example there. And then we say, okay, now what about if I have a rectangular coordinate right on an axis? How do I deal with that? That's what we talked about here. And now we're going to get into something a little bit trickier, and we're going to need this for our next unit. Okay, so what we have here is I need to transform not a polar coordinate, but a polar equation. Well, what does a polar equation look like? Well, a polar equation has an r in it, and it has a theta in it, because that's what we have. If you think of input and output, x and y, okay, well, we have r and theta. So here we are. I have a equation here. I know it's a polar equation because its variables are in terms of r and theta instead of x and y. It says, how do I convert this into a rectangular? Well, I use some of my identities. Like, for instance, what is r squared? That is by Pythagorean square root of x squared plus y squared. All right, I don't have an r squared, so that's my first move here. I can multiply both sides of the equation by r. And then when I do that, I have two substitutions I can make. All right, I have a rectangular coordinate identity for r squared. And then I also have a polar coordinate or rectangular coordinate identity for r sine theta. That's y. Okay, so now I've converted my equation, instead of r's and thetas, into x's and y's. And then I kind of clean this up and put it into my general form. And then we notice from our conic sections, A and C, A times C is positive. So this is going to be some sort of an ellipse. Actually, I think this one turns out to actually be a circle. And what I can do then is general form is usually okay. What if I actually need to plot this thing? Well, we learned from our previous section on conic sections that I can do that by completing the square. And then I can go from general form to standard form, and indeed it is a circle, and then I can go ahead and plot that if I wish. Center at 0,2, radius 2. Okay, so that's how we do that. All right, so usually general form is good enough. If we need to do better than that to actually plot this thing, then you need to complete the square and convert it to standard form, which we did in our conic sections. Okay, let's go the other way after an example problem. All right, so let's do an example problem here. Okay, so this is, it's a polar equation because everything is in r and theta. My strategy works the same way. I'm going to multiply both sides of r. Then I'm going to substitute in my rectangular identities. And then I'm going to get this into general form. Then I'm going to get this into standard form by completing the square. Don't be intimidated. What's the coefficient in front of the x? It's -1. Tear it in half. It's 1/2 and square it. So that's what completes the square. All right, so to complete the square, I've got this guy and this guy. So I have to also add them on this side of the equation. And then after I complete the square, I can mess around with this guy again, and I see that it is probably another circle, maybe an ellipse. It is another circle. All right, its radius is square root of 1/2, which is √2/2, centered at x equal 1/2, y equal 1/2. All right. So that was a good example problem. Let's go the other way. Let's convert a rectangular equation to a polar equation. The strategy is the exact same thing. All right, so this is obviously a rectangular in terms of x and y. All right, what's my next step? I substitute my identities in. I have an identity for x, and I have an identity for y, and I'm going to put those in and do some algebra. Clean things up a little bit. Okay, so there I am in polar. You got to kind of go, well, why didn't I distribute the 4? I distributed the r, but I actually split the 4 up. And actually, this right here, this is actually usually going to good enough, but we did something a little bit clever here. And the clever thing I did here is I recognize that 2 sine theta cosine theta is a double angle identity. So I just kind of took that a little step further. All right. So if you got to this point, great. This is even just better for simplification. All right. But I could be happy with this guy. All right. So let's do another example. Okay. We're going to convert this one into polar. All right, so what are we going to do? There is my identity for y. There's my identity for x. I square both sides. Now, how do I clean this up? Well, I divided both sides by r. And then I'm going to divide both sides by cosine theta. In sine squared theta divided by cosine squared theta, that's sine times sine divided by cosine. Sine divided by cosine is tangent. And so that leaves me tangent theta, sine theta equal 2. Now, how do I know when I'm done? I mean, how do I know to go from this format right here? Why can't I call that good? Because the standard format for a polar equation is that we equal a constant. And so that's how far you have to take it. I mean, is this correct? Yes, it is. But we need to kind of solve it for a constant. Okay, so you should then be able to do all the problems in the homework assignment. There's just a few there at the end that require you to transfer back from rectangular to polar and polar coordinate. And we'll have some warm-ups on those tomorrow. And then you should be good to go. And we can move on to the next chapter. Thank you for your time.